Quadratic equation proofs down is what we are going to concentrate on in this next lesson. Please don't forget to subscribe to the channel. Now, here we have a question which says the roots of the equation x squared plus that differ by 2. So those roots of this equation, their difference is 2. Comma, show that p squared is equal to 1 plus q. Now, the idea is those roots you are getting, when you subtract them, the difference should be 2. There are many ways you can get these roots, but I'm going to show you the easiest method. Now, if I want the roots, of course, if I say the first root is alpha, now if I come here and I say my roots, if the first root is alpha, it means that if the difference is to be 2, then it's going to be, I'm going to subtract from this, I add or subtract 2. So you can say it's going to be alpha plus 2, because when you subtract this from, when you subtract this from this, you get 2. Or the other pair can be alpha, alpha minus 2. When you subtract this from this, the difference is 2. So you either take this pair or this. Or you can even take alpha minus 4, alpha minus 6. As long as when you subtract them, you get 2. So now, allow me to use this pair. So if I take this pair now, remember I need the sum of this pair. So 4 alpha, alpha plus 2. You can try this pair every time. It's going to give you the same proof there. So we need their sum. So the sum we add this root plus this. But we say the sum of roots is given by negative b over a. So we need b and a. But remember, the roots we are getting, they are for this equation. So if you compare with the general, from here I see that our a is 1, our b, the coefficient of x, here the coefficient of x is 2p, and here when you compare, so that our c is q. So just substitute here, so this will be now negative into our p, our b, which is 2p, the whole over a, which is 1, and this is going to be negative 2p. So from here, if I add, I get 2 alpha plus 2 equal to negative 2p. And then divide through, we can divide through by 2, so that we have now 2 alpha plus 1 equal to negative p. If I make alpha the subject, so that our alpha here will be negative p. And I take this side, it becomes negative 1. Then I come and I get the product of these two roots. So the product of roots is going to be alpha plus 2. When you multiply these two. But we say that always the product is equal to c over a. What is my c from here? And my c from here is q. My a is 1 which will be q. Now from here, that our alpha into alpha plus 2 is equal to q. But we have what alpha is from this equation here. So the number is alpha into alpha plus 3 equal to q. Now my alpha from here is, our alpha is negative 1, negative p minus 1, and we put here we have negative p minus 1 plus 2 equal to q. Substituting where there is alpha, we put where there is alpha, we put it there. Our alpha is this, but remember we are adding the 2. So we can simplify this, we shall be adding negative p minus 1 into negative p, and we simplify this, minus p, minus 1 plus 2, we get a positive 1. So here, what the remaining with is to expand. This times this, negative p times negative p, we get p squared, negative p minus times 1, negative and negative, we get positive p, negative 1 and 1, we get 1 according to q. So start this and this they cancel. So p squared minus 1 is equal to q. So now my p squared, you see, we make p squared a subject. So we take this side. So we take this side, is that p plus 1. Or you can rearrange the according to the proof. This is 1 plus q, and that will be our proof. There, as simple as that. Now, you try every time this pair using the same idea. You're not going to get the same answer. Anyway, we leave that. Let us come to this one now. If the difference between the roots of this equation, ax squared is 1, prove that a squared is equal to b squared. Now we are talking about the difference. Still the same idea. When you subtract those two, the difference should be 1. Here they told us divide by 2. It's the same idea but different language. So in my solution, now the equation they are giving us is ax squared. They are giving us the genome equal to 0. So I'm going to select roots b. The difference should be 1. So now let me use the idea. I told you you can use, if you say, you can use either alpha, then alpha plus 1, or you can use alpha minus 1. Now, because in this question we use this one, now allow me to use this pair. 4, now 4, alpha over alpha minus 1. Now I'm going to use this, that is going to give me the same proof. Here I use when I'm adding the 1. Now here, here I use when I'm adding the 2, because we are dividing by 2. Here they are dividing by 1, so meaning I use this when they are adding. Now let me use this proof. Now, we need to get their sum. So the sum is going to be, we add the roots. And you say it's always giving us negative b over a. But because this is the yellow, it remains the same if you compare. This is our a, this is our b, this is our c. If you compare with the yellow, remember we derived it from this. So this one is going to be our negative b over c, doesn't change. So from here I have 2 alpha minus 1 equal to negative b over a. So you make alpha the subject. So here my 2 alpha will be, take this side and get negative b over a plus 1. So you can easily get the LCM. You multiply there, you have negative b plus a over 1. Over 1, so here we are of course multiplying up and down. So if you divide them by 2, your alpha will be, allow me to start with a. So I have a minus b over 2a. If I divide through by 2. By 2 this side, by 2 this side. This is going to be divided here. Then I come and I get now the product. The product would be now alpha into alpha minus 1 equaling c over a. Why am I not changing? Because this is my general quadratic equation. It's always c over a if you have the roots. Now, here I have my alpha. So my alpha is here. So I'm just going to substitute. So I have now a minus b over 2a into now a minus b over 2a minus 1 equaling c over a. So where there is alpha, I'm putting it in here. So this was 1, then this is 2. I'm put 1 in 2. That's what I'm doing. So here, you can cross multiply together LCM. So I have a minus b over 2a into, this is over 1, cross multiply, get a minus b. I multiply this here, I have this times this, the whole over 2a equaling c over a. So here we can easily simplify a minus b over 2a into, can we simplify there? You see this and this, I have negative b, then a minus 2a, I have negative a, the whole over 2a equaling c over a. Now there are 2 ways. You can either factorize out this negative or you can multiply direct. So this one is going to be now, when I multiply now this part and this and this I get, this and this I get negative ab, this and this I get minus a squared, this and this I get plus, this and this I get plus b squared, this and this I get minus, plus now ab, the whole over, this and this will get 4a squared equaling c over a. So what we can now start this one, simplify. simplifies with that. Get now negative a squared plus b squared equaling to c over a. So multiply through by this denominator. So I use a squared, I use 4a squared. Answer this, we're going to cancel this, get negative a squared equaling to this a goes with 1a, get 4c. Now if you want to start an up proof, they are making a squared subject. So from here, if I take a squared aside, I get b squared minus 4ac equaling to, and we take this side from negative to become now positive. And bring this side, it becomes negative. So if you rearrange according to the proof, you get b squared minus 4ac like that, and that's our proof members. So to start, when you use this now, it also worked. So it means as long as the difference is 1, the answer is going to be the same. I wish you